let's conclude about factors and multiples. Okay. So how can we conclude factors and multiples? So is there any number which is a factor of the number itself? Yes, obviously we have the factor for every number, right? So for every number there is one factor, which is the number we have in every factor. We will have that number. So which number is that? That is, we will have 1 in every factor. So we will have 1 in every number, right? Every factor of a number. Right? For example, if we have factors of 4, so 1 is a factor of 4. Obviously, we can tell that 4 into 1 is 4. 1 into 4 is, so 1 is the factor of 4. Next we can tell 18. 18 into 1. 1 into 18. So in every number, in every factor, we'll have 1 as the factor of every number. Okay. Next, second one, what can we tell? So we can tell that in first one, 1 is the factor of every number. Next, in second one, can we have the factor of a number? So children, first one is there any number which occurs in every factor of a number? Do we have any number which occurs in every factor? Yes, we have a number that occurs in every factor. So which number is that? We have 1. 1 occurs in every factor of a number, right? For example, we have 6. We have 1 into 6. So 1 is a factor of 6. Next, if we have 5, 5 is a factor of 1. 1 is a factor of 5. If we take 18, 1 into 18 is 18. So we can tell that 1 is a factor of every number. 1 is a factor of every number. Okay. Next, second one. Can we have a number which is a factor of itself, children? That is, if you have the factor, for example, 7. So can we have the 7 as the factor of itself? Like, is 7 factor of 7 only? Yes. We'll have a factor of that number itself for every number. So we can tell that every number is a factor of itself. So every number is a factor of itself. So for example, what can we tell? We can tell 7 is a factor of 7 itself, or 2 is a factor of 2. Then 5 is a factor of 5. So we can tell that the factor of that number itself is a factor. So every number is a factor of itself. Next, third conclusion. So let us take third is every factor a number is a exact divisor of number? That is, if every factor of a number is an exact divisor of that number, children, as I told you previously, exact divisor of a number is a factor of a number, right? As I told you, right, in the previous topic, exact divisor of any number is also a factor of a number. So for example, let us take 16. So what are the factors of 16, children? The factors of 16 are, in 16, in which in our tables it will go? 1, 2, 4, 8, 16. So the factors of 16 are 1, 2, 4, 8, 16. So this is the exact divisor of 4, because see, if we divide 1 by 16, do we get remainder of 0? Yeah, we can tell that 1 is a divisor of 16. Next, 2 if you divide by 16. So 2 8s are 16. So again you will get remainder as 0. Next, 4 if you divide by 16, you will get remainder as 0 again. Next, 8 if you divide by 16, you will get remainder as 0, because 8 2s are 16. Next, if you divide 16 by 16, you will get remainder of 0. So what can we conclude with this, children? We can tell that the factors of a number is the exact divisor of the number, because we are getting 0 as a remainder. So what can we tell? That it's a exact divisor. So this number is the exact divisor of this number, right? So 16 is the exact divisor of 1. So we can tell that every factor of a number is an exact divisor of a number, is an exact divisor of an number. Okay. So we can tell that the factor of a number is same as the exact number divisor number, will get the same answer. So we can tell that every factor of a number is the exact divisor of that number itself. Okay. So these three are first three conclusion. What is first conclusion? We have concluded that 1 is the factor of every number. So that 1 will have in every factor of a number. Next what did we see? We saw that every number will have its own factor, right? Every number will have its own factor. Next, in third one, what did we see? We saw that every factor of a number will have its exact divisor of a number. So if we divide any number with the factors, we'll get the exact factor of the number. Next, fourth conclusion. So what did we learn with factors, children? We saw that factor of a number will always be less than or equal to that number. So what with example I'll explain you. That is, for example, let us take 34. So what are the factors of 34, children? Factors of 34 are 1, 2, 17, 34, right? So with these numbers, do we have factors of 34 less than 34 or greater than 34? We have the factors of 34 numbers we have, no, that is 1, 2, 17, 34. That numbers is less than 34 or greater than 34? That numbers are less than 34, because 1 is less than 34, 2 is also less, that 17 is also less, 34 is equal. So we can tell that every factor of a number is less than or equal to the given number. You can tell that every factor of a number is less than or equal to the given number. It can't be greater than the number. Other example, let us take for 64. 64. So what are the factors which are less than 64, children? Sorry, what are the factors of 64? 1, 2, 4, next 8, next we have 16, next 32, next 64. So these are the factors of 64. So see your children, the numbers 1, 2, 4, 8, 16, 32. These numbers are less than or to 64 or greater than 64? 1, 2, 4, 8, 16, 32 are less than 64, right? Next 64 is equal to 64. So the what we have concluded is right? So every factor of a number will be less than or equal to the number. It can't be greater to that number. Next, fifth conclusion. For example, let us take 76. So 76 has how many factors, children? 76 has how many factors? 76 factors are 1, 2, 4, 19, 38, 76. So 76 factors we have 1, 2, 3, 4, 5. 5 factors we have for 76. Right? You can leave the same number. 76 you can leave, then count rest of them. For 76 we have 5 factors, right? You have 5. Next, for 136, how many factors you have? So 136 you have factors from 1, 2, 4, 8, 17, 34, 68 and 136, right? So how many factors you have for 136? 1, 2, 3, 4, 5, 6, 7. So you have 7 factors. Right, children? So here what can be observed for any number, the factors we can write are countable. The factors are countable, right? Next, suppose if you have a bigger number. Suppose if you have a bigger number, that is 10576. If you have a bigger number, what will you do, children? Is that countable or uncountable? For 10576, the factors are 1, 2, 4, 8, 16, 661, 1322, 2644, 5288, 10576. So, see, for bigger number also we have factors which is countable. So, what can we conclude with this observation, children? We can tell that the number of factors of a given number can be countable, that is finite. So the factors of a number are always finite. We can count the factors of any number. For bigger number or smaller number, we can count the number of factors. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 factors for this, right? So it's countable. So we can conclude that number of factors of a given number are finite. Finite means we can count the number of factors for the given number. Okay. For the factors, we can count the number. Okay. In fourth one, what did we see? We saw that every number, the factors of every number will always be greater, less than or equal to the number. It can't be greater than the number. That is for only factors. For factor, we can tell that its factors are less than or equal to the number. Next, for fifth one, we can tell that number of factors of a given number are always finite. So, for factors of a given number, as it is less than or equal to, we can count the number of factors for a given number. If it is a bigger number or smaller number, we can count the number of factors and tell that how many numbers are there, how many factors are there, how many factors of a number did we find for a particular number. So next let us see sixth one. Sixth one. See children, what are the multiples of 7? Multiple of 7 are, in which table 7 will go? In 7 tables, 14 tables, next 21, 28, then it goes on. Okay, so it goes on. We can't, it will be it keeps on continuing. So we can tell that it is a continuous. So we can't count the number, but here observe that the multiple of 7, what are the multiples of 7 we have got? 7, 14, 21, 28 and so on. So multiple of 7 we have got, next 14. So 14 is greater than 7, right? Next 21 we have got. So 21 is greater than 7, correct, right? Next 18 is greater than 7. So it goes on. So what can we conclude with? We can tell that every multiple of a number will always be greater than or equal to the given number. I'll take one more example for you. I'll take 6, okay? What are the multiples of 6 we have, children? 6 2s are 6, 6 1s are 6, 6 2s are 12, 6 3s are 18, next 24, next 30, next it keeps on going. So here also see we have 6, 6 is equal to the given number. Next 12, 12 is greater than the given number. Next 18, 18 is greater. So the multiples which we are getting is greater itself, right? Next, if we take one more example, that is 9. So now multiple of 9 is 9, 18, 27, 36, 45 and so on. Here also you can observe that 9 is equal to 9. Then rest on all numbers are greater than 9. So what can we conclude with this example, children? We can tell that every multiple of a number number is greater than or equal to the given number. So it will be greater than or equal to the given number for multiple. For every multiple, it will be greater than or equal to. For factor of every number, it will be less than or equal to. You have to keep this difference. Okay. For factor, it is less than or equal to. For multiple, it's greater than or equal to. Next, seventh one. For example, here only we saw 7, like it goes on repeating. For example, if I take 5 multiples of are 5, 10, 15, 20 and so on. So it keeps on continuing. So can we count the number of multiples here? We have 1, 2, 3, 4 and so on. So we can't count the number of multiples here. Right? For 6 I took here. So for 6 you see we have 6, 12, 18, 24, 30 then so on. So can we count the number of multiples here? No, because it keeps on going. Like we have so many numbers repeating. So we can't count the number of factors, number of multiples for a given number. So we can tell that the number of multiples of a given number is uncountable because we can't count the number of multiples. Number of multiples for a given number is uncountable, that is infinite. Okay, and we can't count the number of multiples in multiples. So in factors, what did we see in this step? We saw that for every factor we can count the number of factors, that is number of factors for a given number is finite. Here what we are seeing for multiple, the number of multiples for a given number is infinite. So you have to keep this difference. This both different is, this difference you can keep in your mind. For multiple it's greater than or equal to, for factor it's less than or equal to, for multiple it's infinite, number of multiples for a given number is infinite, there the number of factors for a number is finite. So these difference you can keep in your mind, and sometimes they can also ask the difference between factors and multiples, so you can write these steps. Okay, next eighth one. So can we have a factor of 7 in 7 as, can we have a 7 as a factor of 7 itself? Yes, we can have a factor of 7 for 7 itself. So for 3 also, can we have a factor of 3 for 3? Yeah, we can have a factor of 3 for 3. So what can we tell that? We can tell that every number will have its own factor. Will have, it's a multiple of itself. Every number, it's a multiple of itself. So every number is a multiple of itself. So We have 3 can be a multiple of factor of any number. The number itself can be a factor of that particular number. Okay. So with these points we can conclude about factors and multiples. So first, what did we conclude, children? We came to know that 1 is the factor of every number. In every number we'll have 1 as the factor. Second one, what did we learn? We learned that every number is a factor of itself. Here also see, every number is a multiple of itself. There we add every number as a factor of itself. So these difference you can keep in your mind so that it will be easily remembered. Okay. Next, third step, what did we have? What did we learn? We learned that every factor of a number is an exact divisor of that number. So factor of a number is same as the exact divisor of the number. Next, fourth point, what did we learn? We learned that every factor, the given number will always be less than or equal to the given number. Next, for multiple, what is the difference we have? For factor we add it's less than or equal to. For multiplier we have greater than or equal to. Next, for factor what did we have? For factor we add the given number is finite. For multiple we have the given number is infinite. Next, 8th point, what did we learn? We learned that every number is a multiple of itself. So in factor we learned that every number is a factor of itself. So these 8 points you have to keep in your mind, and if they ask any difference between factor and multiple, you have to write the difference between these two. So next, let us learn the perfect numbers. Okay. So the factor of 6. What is the factor of 6, children? We have factors of 6 as 1, 2, 3, 6. Right? We have 1, 2, 3, 6 as the factors of 6. Next, if we add 1, 2, 3, 6, what is the answer we'll get? We'll get 12 as the answer. So this 12, how can we write as? 12 we can write as 2 into 6 or 6 into 2. We can write in either way. So what can we conclude with this example, children? We saw that 6, the factors of 6 are 1, 2, 3, 6. And if we add those factors of a given number, we'll get the sum. The sum of a given number will get 12. So we can tell that the sum of a factors of 6 is equal to that number. So if we add all the factors number, we'll get 12. So we have 6. So if we double 6, what will we get the answer? We'll get 12 as the answer. So the given number is always twice as the sum of the factors of a number. Okay. So if we take one more example, that is 28. So what are the factors of 28? 28 factors are 1, 2, 4, 7, 14, 28. So the factors of 28 are 1, 2, 4, 7, 14, 28. So next, if you add all the factors, that is 1 plus 2 plus 4 plus 7 plus 14 plus 28. So if you sum all the factors, what is the answer you will get? So the answer you will get is 56. So if you add 28 plus 28, what will you get the answer, children? You will get 56 as the answer. So what can we tell? So 56 we can write as twice as 28. Okay. So we can conclude that a number for which sum of all its factors are is equal to twice the number, twice the number. So a number for which we have got is the sum of all the factors will get the twice the number, right? So 6 plus 6 will get to 6 twice. If we multiply, you will get 12. So twice, if we add twice, 2 times the 28, will get 56 as the answer. So we can tell that the number in the sum of all factors of a number is equal to twice of that number. So if we calculate twice 6, we'll get 12 as the answer. So if we calculate 28 twice, we'll get, so we can write as 2 into 28 or 2 into 6. So what do you call this as? You call this as a perfect number. So if you get answer as the twice of the given number, then you'll call it as a perfect number. Okay. So here what can we tell? Here we can tell that 6 and 28 are perfect numbers. Okay. With this example, we saw that 6 and 28 are perfect numbers. Okay. You can take few more example and see if it is a perfect numbers or not. I'll show one more example. I'll take 10. Okay. So for 10, what are the factors of 10? 10 is 1, 2, 5, 10. Right. So if you add 1 plus 2 plus 5 plus 10, what is the answer you'll get? 8 plus 10 you'll get. So you'll get 18 as the answer. So you got 18 as the answer, children. But if you add 10 twice, what is the answer you'll get? You have to get 20, but we are getting 18. So we can tell that 10 is not the perfect square, because if we add all these factors of a given number, we have to get the twice of a number, but we are not getting twice of a number, right? So we can tell that it is not a perfect number. Okay. If the answer is twice of a number, you can conclude that it is a perfect number. If it is not the twice of a number, you can tell that it is not a perfect number. Okay. So next, let us take some examples. So with this, what did we learn till now, children? We learned what is factors and what is multiples, and how can we conclude with the factors and multiples, and we also saw some differences, and we also saw the perfect number. Okay, so these are the topics we learned till now. So let us next solve some example problems. Okay.